In example 9, I'm gonna go ahead and make u the ln of x. And the reason is because when I do du, I get 1 over x dx, which is exactly what we need. So the u I chose has a derivative in the problem. So I end up getting u, and then 1 over x dx becomes du. And so if I do antiderivative of that, I would add 1 to the exponent. So that'd be 2, divide by it, and then I need to plug u back in. So I'm going to have 1/2 natural log x squared from 1 to e. So we're going to plug in e. And then we're going to plug in 1. So natural log of e is just 1. 1 squared is 1, so we just have 1/2 times 1. Natural log of 1 is 0. 0 squared is 0. Half of 0 is 0, so we end up getting 1/2. And then for our last two examples, we've got this theorem here that says that if the function's continuous on the interval and the function's even, that is that if you plug in a negative and it would go away, if you're going from a negative number to the same number positive, you could just go from 0 to the positive number and just double your answer. If the function's odd, that is if you plug in a negative and you get a negative function out, and you're going from a negative number to that positive number, the answer is always going to be 0. So this would be if we've got a really difficult function where it's too hard to actually find the antiderivative of it, we can use these to help simplify the process. So if we look at example 10, we know this is an even function because if we plug in a negative, it would go away. So instead of going from -2 to 2, which they're asking us to do, we can just go from 0 to 2, which is half the interval, and double the answer we get. And so it just makes the numbers easier, and they got that answer. Here we've got an odd function. If I plug in a negative, it would make everything negative. So they're going from -1 to 1. Since those are the same number but opposite sign, the answer is just 0, and we don't actually have to go through the process of finding the antiderivative of it. If you look at the graph, it kind of shows you instead of going from -a to a in this function, you just take one part and double it. And here, instead of finding the integration, we know that from 0 to a and from 0 to -a are going to cancel each other out because you've got a positive area and a negative area.